Replace the two wrenches and the force acting on the pipe assembly by an equivalent resultant force and couple moment at point O. So we've got these two wrenches here in this force. We want to replace all of this by an equivalent force and couple at point O. So wrenches, what's a wrench? Well, for the most general case of a force couple system, so in 3D, forces, couples, whatever, in random directions, a wrench is the most you can simplify a general system. So in some of the previous example problems, we've done problems where it's a special case, like a coplanar force system or parallel force system or concurrent force system. Those you can simplify even more than a wrench. A wrench is at a single point, you have a force and couple moment at the same point in the same direction. So not just at the same point, but also they're in the same direction. I don't know why they call it a wrench. It seems more like a screw. You know, a screw, you're turning it, you're applying a torque, like a couple moment, and also there's that linear force pulling the screw in or out. But so the special cases we can simplify past the wrench, but in the most general case, the wrench is the most you can simplify the system. So we've got two wrenches here and a force. You could simplify this. You could say, let's simplify this to have one wrench, just only one wrench at point O. But you can simplify it however you want. It looks like a good idea here. Why don't you have a wrench here on this pipe leg and a wrench here on this pipe leg, right? You can simplify the system however you want. So, okay, what is a wrench? How do you get a wrench? Well, the first thing we learned in some of the first example problems we worked in this section was that you can take a general force system, completely general, and simplify it to a couple moment and a force at a point, both acting at the same point. They're not in the same direction. They're not necessarily perpendicular to each other. The couple moment axis is in some random direction in 3D space, and so is the force axis. If it happens to be the case that the couple moment axis is perpendicular to the force axis, then that's one of the special cases. That's what happens for a coplanar force system or parallel force system. You get the same result, this perpendicular couple moment and force, but the way you analyze those systems is a little bit different. But it's a similar result in that once you have that perpendicular couple moment, you just move the force perpendicular to the couple moment axis, and then you're able to remove that perpendicular couple moment and just have the force. But it's not as simple in general when the couple moment is not perpendicular to the force axis. So again, we worked examples where we just stopped at once we found the couple moment and the force at the point, that was it. But you can go further. You can say, okay, so the couple moment and force axis, that makes a plane, right? Two axes make a plane anywhere in 3D space, just randomly oriented in 3D space. Well, within that plane, you can take the couple moment and break it down into components that are perpendicular to the force axis and parallel to the force axis, right? From there, you can move the force perpendicular to the perpendicular axes. So like you see how just like we did with the coplanar and parallel force systems, you move the force a distance d that's equal to, well, the force times the distance d is equal to the moment, and remove that perpendicular couple moment, right? We did this, and that's what we did with the coplanar and parallel force system. But for the general case, we still have this parallel couple moment. But this is just a couple moment, right? For all of these systems that we simplify, we're reducing it to a couple moment and a force at a point. It's a free vector. The couple moment, like this couple moment here, is a free vector, but we just go ahead and place it at the same point as the force, just because that's the simplest form. So this is a couple moment. Well, okay, now let's just move this couple moment to the same point as the force. And there's your wrench. But here, we're going in the reverse direction. Now, what we could do is we could go step by step and totally do the reverse wrench process for each of these wrenches, where we find the couple moment in the random direction and the resultant force for each of these wrenches at this point. From there, we would then sum the couple moment vectors, sum the force vectors to get the resultant force and couple moment at point O. But we don't have to do that step-by-step reverse wrench process. What we can do is, let's just analyze this from what we understand. So these are free vectors, right? This is the component of the couple moment that was parallel to the force at, let's say O. Let's say we're talking about O at any point. You can do this for any point, but we're looking at point O, right? We moved the force, the resultant force, off to get rid of that perpendicular couple moment component. Then we just took the parallel couple moment and brought it to the force. Well, let's just bring it back. Let's bring these two back. And then what we can do is, what would be easier is, let's just find the equivalent couple moment of like this 300 Newton force and this 200 Newton force about point O, like we've done before. That would be easier than trying to like reduce, do a reverse wrench. We'll get all of these couple moments vectors and then we'll just sum the vectors and then sum the forces, right? So like doing the reverse wrench process would be more involved. You can think about it like this. So, because I'm just trying to give you some intuition. If we're going to reverse this wrench at point O, bring the couple moment back to point O, then that's the parallel component. We could bring the couple moment and the force back to point O. So this is the couple moment, the part of the couple moment that's parallel to the force. But then what about the perpendicular component of the couple moment? Well, that's the moment of the force about the x-axis, right? This direction. That's this perpendicular component. So you get 300 newtons times 0.5, you get the perpendicular component. Now you've got the parallel and the perpendicular component. You get the resultant vector and the vector direction of those two, and that's the couple moment. You have the force and couple moment at point O. For this one here, you're going to have, so you bring this couple moment back to point O, that's in like this direction, right? That's parallel to the force. But then there's also going to be a couple moment that's along this axis here, that's perpendicular to the force axis, or it might be more something like that, right? You would get that by, you would say, so you have a moment, you have the forces in this direction and also a component in this direction. You have a moment about the x and a moment about the z, which creates this resultant moment that's perpendicular to the parallel force moment, couple moment, right? You would actually, you wouldn't need to find the moment about the x and z. You would just say 200 times this moment arm distance from this axis. That's the rotation it's causing about this axis. So you have the parallel couple here, the perpendicular couple, do a vector sum, get that couple moment, move the force to point O, the 200 Newton force to point O. So you have your two couple moments and your two forces from each of these wrenches. Then you could also move this 100 Newton force to point O, but there is no moment of the 100 Newton force about point O. So then you just sum all the force vectors, sum all the couple moment vectors, and there you go. And you're done. But we're not gonna do that reverse wrench process. Let's just do it as easily as we can. So we're moving these couple moments to point O, these parallel couple moments. Now, what's the moment of the 300 Newton force and the 200 Newton force about point O? We could do R cross F, or what we're going to do here is just find the moment of the force about each of the axes. So we're going to kind of manually get the moment components. Okay, so this 300 Newton force, there's no moment about the y-axis, no moment about the z-axis. It's just about the x-axis, and it's in the positive. It's directed along the positive x-axis. So 300 times 0.5, that's 150. So 150, and that's in the positive x direction. Okay, actually, let's do this. We're going to, the resultant moment, couple moment at point O, right? That's what we're looking for. Okay, we have 100K. What else? We've got this moment here, which is 180 cosine of 45 I hat, and then minus 180 sine of 45 j hat, right? Or k hat, right? That's these two couple moments. Now, okay, coming back here, 300 times 0.5 is 150. This is positive 150 I hat. You see, this is the positive x, it's rotating about the positive x-axis. And then there is no component of this, or for moment of this force about the z or the y-axis. Okay, now this 200 Newton force has a moment about, so it causes rotation about the z-axis and the x-axis, but not about the y-axis. So the x-axis, it's causing rotation about the negative, in the negative I hat direction. So minus 200 sine of 45. Okay, the moment arm about the x-axis is 1.1 I hat. Okay, now this component is what? So positive z hat is in this, so this is negative, about the negative z direction. Okay, so negative 200 cosine of 45 adjacent over hypotenuse, and then this is, the moment arm is also 1.1, and that's k hat. And there you go. This is the moment, the couple moment, the net resultant couple moment from these two wrenches and this force about 0.0. This force creates no moment about 0.0. So we've got, for I hat, we've got 180 cosine of 45 plus 150 minus 200 sine of 45 times 1.1. So this is I hat. Okay, there is no j hat, plus 100 minus 180 sine of 45 minus 200 cosine of 45 times 1.1 k hat. Okay. $121.7 I hat. Right. Minus 182.8 k hat. So there you go. That's the couple moment. The equivalent couple moment at 0.0. Now the force, just add up all the forces. Just bring the forces to 0.0 and do a vector sum. So the resultant force, and this, you want to make sure you designate what is a vector. You either bold this or you put the vector symbol, right? This is a vector. Okay. So we've got 300 K hat plus 100 J hat. That's this force. All right. Now, plus 200 cosine 45 I hat minus 200 sine 45 K hat. So 200 times cosine of 45, 141.4 I hat plus 100 J hat, and then $45, 158.6. Okay, yeah, and then the units are Newton meters, and then this is going to be in newtons. And there you go. So if we could erase all of these forces in couple moments and put this couple moment at point O and this force at point O, and that would be an equivalent system.